Good morning, everybody. I'm Philipp Stiefel, and I'm afraid I don't have time for any further introduction now, so let's get right on topic. Automatic testing in Access and VBA. Who of you does something in that regard, some sort of automatic testing? Please raise your hand. 1, 2, 2.5 I count. That's not many. And I guess there's a reason for it, because when you read about automatic testing, unit tests and stuff, it's all written or presented from a very idealistic view. And you have to do it the right way or don't do it at all. And it's really hard for people like us working with Access and VBA to do it right. I think it's actually almost impossible. And so we are basically left out in all this testing community. And so I would today like to show you a pragmatic approach to do automatic testing in Access and VBA. So let's start with a little story, which I also have to cut short. Like 7 years ago, I started a new project with a new client, and it turned out to be a very long and very huge project. And it was about loan claim calculations. And I and my team were supposed to develop a loan claim calculation application. And that was, the first steps were pretty easy when we talked about the initial requirements. We developed the application with a bit of interest calculation and payment bookings and stuff, an account statement. Pretty straightforward. A little bit complicated here and there, but it was doable. We created that, it worked, the customer was happy, all the users were happy, and everyone lived happily ever after. No, not quite, because you can guess what happened. New requirements came up, and quite a lot of them over time. And that caused a problem with testing the application. At first, it was possible to test the whole claim calculation in a couple of minutes. But then different account types came into play, different legal regulations for different countries, and all stuff like that, which kind of multiplied the options for the outcome in the claim calculation, because lots of them could be combined with each other, and we very quickly had like hundreds of different code paths we would have to test. And beginning of this year, it took over an hour to test the whole claim calculation logic manually. And you need to keep in mind, you code a bit and think, yeah, okay, this does what I intend to do. And you think, yeah, that is good. And then you go to testing and spend an hour, and if you are unlucky, you are just at the end of that hour and notice, oh no, in this special case, my code does not work. And you have to go back to the code, change it to account for that special situation, and go through all the testing again. And that was a huge problem. The craziest part is that I hate repetitive work, so you can't see me going back an hour and testing and then doing a little bit of coding and doing another hour of testing. That is not going to work. But even if it would work, it would consume so much time. And in the end, it was so bad, we kind of deferred all sorts of bug fixes and new features and said, yeah, it's too expensive and too difficult to implement those features. And we just defer them, and the user will do a little bit of calculation in Excel on the side. And we had racked up about 30 major issues or new features that we did not implement because it was too costly. And then I started to implement automatic tests. And that is what happened. It took me about a week to implement tests for all the functionality that was already there. But after that, the effort reduced drastically, because there were only bits and pieces where I haven't had a test and had to have one and added that later. But after all those tests were in place, I needed to spend a little bit more effort to add a new test for new functionality. But beyond that, all those testing hours that were spent on the project were practically eliminated because the tests were run very quickly. And so that is the reason why I test, to manage the complexity of a huge application where there need to be changes made that affect all the logic that is already there. To have the confidence that I can quickly put out a new version and I can be pretty sure I don't introduce a bug in there, I don't break anything that was working before, and in this way I increase the quality of the application massively. And within another week, after implementing those tests, within another week, we eliminated all those 30 bugs and missing features, except one or two which were bigger things. But almost all of those were done within a week, and that would have taken us at least a month before, probably longer. We deferred it for years, some of those. So that is the reason why I test automatically. Before we get into a couple of demos, I would like to talk a little bit about terminology. So you all probably have heard about the unit test. The unit test tests a unit in isolation. And usually when you read about unit tests, that are these texts are written by people working in very object-oriented languages, so they consider a unit to be a class, usually. That does apply to Access as well, but a unit is characterized as being independent of, or at least as independent as possible, of external stuff around it. So in Access, a unit could also be a function or a procedure. And it's only important that dependencies are removed or replaced by something else. In other languages, you would use stubs or fake objects or mocks to kind of abstract dependencies away. You can imagine that like you have a function that queries something from the database and that is used inside your class, and you would kind of replace the database by some static data store that returns static values, the values you need for the test. And I'm not going into much detail about the differences between stubs, fake objects, and mocks. They're just simplifications that abstract away external dependencies. Well, how do you do it? With code. The unit tests are done quite close to the actual project you're working in, and in Access you would probably do most of that inside your Access or VBA project. And if you do it with code, of course you, the developers, are the one doing the testing with unit tests and writing the tests. One step up the ladder is the integration test. And the difference here is it is a combination of units that is tested. They are integrated into each other, but there is still dependency that is replaced in that, even if you need to connect to the internet or stuff that might be time consuming or might break easily. That is something that would still be replaced in an integration test, if possible, of course. It's once again done with code. It's once again done very close to the actual project. And in Access, you would probably do it inside your Access code base. And once again, it's done by the developer, obviously. Now, the next level up is not our topic today, just for completeness sake, real quick. The next one is the system test, where the real application, the whole application, is tested either manually or with coded UI tests, with UI automation. And that is either done by a developer or by a dedicated tester, if you have someone on that team. And one step up is the acceptance test, and that is once again testing the whole system. But the important point here, this is done manually, either by product management or by your customer support, or ideally by real users of your application, by people who do know nothing about the internal implementation, not developers. That's the important part here. Well, let's look at the essence of automatic testing. What are the traits of a good automatic test? The most important one is it needs to have a binary result. A test can either pass or it can fail. The result can be good or bad. There's nothing in between. If you need to look at the results and say, oh yeah, well, 8.7, well, that doesn't look too good, but maybe it's just passed. If you have to do some sort of interpretation of the results, the test is not suitable for automatic testing. You need yes or no as an answer in an instant. And these results have to be reproducible. If I ran the tests 10 minutes ago and run them again now and did not change anything in the code under test, the application logic, or in the test itself, I expect it to yield exactly the same result as 10 minutes ago. It's worthless if it's only working once and then you need to reset some stuff, or if it only works in the morning but not in the evening. That's no good. It needs to be reproducible all the time. Another important trait is fast execution. If you run your tests and that takes 10 minutes and you go fetch a coffee in between, you come back and you probably can hardly remember what were you doing, what would you like to test, what was the expected outcome, what are the important bits you don't know anymore. It will slow you down. And one of the consequences is you will not test as often as you should. If you know it takes too long and I have to wait, it brings me out of my flow, you will test later. And we all know later probably means never. And at least it is too late, because one huge benefit is that you have quick feedback, and that requires your tests to run within seconds. And tests should be easy to run. Ideally, you just type a line of code and hit enter and your tests run, or you click a button and your tests run. It should be really, really easy, for the same reason that you do not defer testing until it's too late, because it's too complicated to run them. What is the anatomy of a test? AAA, arrange. We set up some preconditions. In classic unit tests, that is usually creating the instance of a class, setting a couple of default values, and after that we act. We run the actual logic that we want to test. And this actual logic should return some sort of result, and then we assert this result if it meets our expectations and if the test passed or if it failed. So, time for the first demo. A really simple test in Access. Okay, I need to switch here. Yeah, okay, great. So I prepared a little function. It's actually from that claim calculation. It was transformed from T-SQL to VBA for this demo. So the code might not be optional or ideal, but the important part is that you have a quick look that this function is supposed to calculate the interest days, the days you need to pay interest on a loan. And no, it's not just date diff, because you see there is a bit of logic in there. You don't need to understand it at all. That's not really anything of your concern right now. I don't expect you to understand it. I just want you to see it. It is a little bit more complicated than you might think at first. So I create a new module. And before I write anything in the module, I would like to make sure my function works. And so I do a little bit of testing in the immediate pane. Bear with me for a second. I'm not so good at talking while typing, especially when I have to type dates in that American date format. So, I'm just calling the getInterestDays function, and I want to calculate the interest days for January 2019. And you will probably say, yeah, it's pretty easy, it's 31 days, you don't need a function to calculate that. But turns out it is not as easy, because in Germany, for example, we used an interest calculation method called 3360. We assume, for the purpose of interest calculation, every month has 30 days, and the year has 360 days. So this function takes this into account, and there are just two arguments here, 30 and 30, that is the minimum number of days in a month, and the maximum for this interest calculation, it's just 30 for both. And let's go. Yeah, you see, January has only 30 days for interest calculation. Now we go to February, and we calculate from the 1st of February till the 28th, and of course it needs to be February here. And once again we have got 30 days in February. But there is a special thing here. If you pay back your loan on the 28th of February, it is only 28 days. So there is a lot of logic in here, and I don't want to bother you any longer with these interest calculation stuff. I'm just going back to the automatic testing, because until now this was obviously not automatic at all. And I'm deliberately showing this because this, what I just done, is probably, who of you does testing complicated functions like this? Yeah, quite a lot. I assume everybody. So, and now the next thing you do, yeah, it works, and you're done, you delete the immediate pane or you close Access, and this is gone. What a waste. I create a little function here and paste the code in here. That would print the code, that would at least conserve these, but that is not what I'm after here. You all know debug print. Who knows debug assert? And more important, who uses debug assert? Yeah, two maybe. I'll show you what it does in a minute. I'll just complete my stuff here. For a minute. So debug assert acts like a conditional breakpoint. If you run code and it hits a debug assert, it evaluates the expression following the debug assert. Excuse me, I'll make that a little bit bigger. And if it encounters an expression that evaluates to false, it will stop on that line. I run the code, there was no breakpoint, but it stops because the condition behind debug assert was false. And that can be used to test things, because the code will run without any other behavior as normal, unless your condition evaluates to false. And now I run my code, and you see it just skipped over the first two function calls, and it stopped at the third, because while doing my copy and paste, I deliberately introduced an error. I assumed that February had 30 days also if you pay back your loan on the 28th. And that is not correct. Obviously, you would rather look for bugs in your code, but there can also be bugs in your test, so this is not too far-fetched. And now I corrected this mistake, and now I've got the dumbest demo ever because I run this and you see nothing. And that is because it just runs and completes and nothing happens. So that would be a passed test. And we could do the same a little bit differently, just for variation's sake. I keep it very simple here. So that is basically another approach to get to the same result. I did I just do if not 30 equals get interest days, then I do an error erase. I deliberately cause an error if that is not the expected result. And yet now I run it and it's once again a stupid example, but if I change the code, then you see I get a deliberate runtime error here because my expected result is not matching the return value from that function. And then I can debug, and that probably would be another good use for the extra resume here if you want to debug the stuff, because I'm yet now in the error race condition. But you see, okay, the error failed, the test failed. So, and now to make it easy to run all this, you can also create a small sub run all tests, and you need to add each test procedure in there at least once for it to be called. And I suggest you put something in there like small debug print, all tests complete. Just quick zoom. It's very, very basic procedure. I just call the individual sub-procedures I wrote. And now I can type in run all tests in the immediate pane. Okay, and I still get my error, so it basically works this way. I get the error, I know something's not right, I can say debug, I'm right where the error occurred, and if you have a huge project, you will have multiple test modules and quite a bit of test code. So it is quite helpful if you immediately jump to the line of the failing test. So I fixed the error, I run this again, and now nothing happens except my all tests complete print. So I know all is good. And all my tests are run. And that is a very basic method to test automatically. So back to the slides. Well, that's the demo. We have seen that. Of course, you can also create a function that returns true or false if the test passes or not. That is another option, and you could create some sort of own framework for that you even add more, convenience to your stuff. And that is what we look at now, tools and frameworks. And unless you were searching expressively for that, you probably not heard of any, but there are a couple of tools and frameworks. I removed the overview over those because it would have taken too much time. So let's just ask ourselves, why would you need, or why should we use tools and frameworks? It gives you a bit of guidance on how to structure your test, how your modules should be named and built, and how your tests should be created, and it adds a bit of infrastructure around your tests that make it easier for you to write tests. Most notably, 2 methods can be put in every test class, because most of the frameworks use classes, but some do use modules. So you would have a module that contains multiple tests, like I did a second ago, and you can also put a setup procedure in there and a teardown procedure. And the framework will run each test, and before it runs the test, it will call the setup procedure, if there is any. And after running a test, it will run the teardown procedure. And these are quite useful to kind of do some more extensive preparation that needs to be done for each test of a certain type. And I will show that in more detail later. And of course, with testing tools and frameworks, you usually get a user interface that will provide additional information, like the number of tests you've got, which tests failed, which passed, which module there was a failure, and all this stuff. And it adds convenience, like the button I mentioned earlier. You have a button you click and it will run all the tests, or maybe only selected tests. So I'd like to introduce you to one particular tool for unit testing in Access. It is based on Access Unit, that is a unit testing framework for Access written in Access and VBA. It was written by Andre Minhorst. It's a very popular German author who wrote a couple of Access books. And he also created this unit testing framework. And I like this because it's really lightweight and easy, and I just can copy it into my Access application. I do not need to install external software. And that is something I could use on site with my clients. So I built a bit on top of that and modified quite a lot and created an add-in, and I call this Access Unit 4, because that is my enhanced version of that unit testing framework. That will be also freely available to you, and it's very similar, and it is compatible mostly. So if you used the basic Access unit, you can also convert to my fork of that. So what we are doing now, we create a new test here. I create a new class module. I just paste in this stuff from minutes ago, and I just replace the debug.assert with test assert, and I should use assert equal here. So, and for the test framework to recognize this class as a test, I need to prefix the class name with test underscore. Just call it test interest. And another thing is I need to prefix every test minute also with test underscore and then a name. So, and now I created a test that will not run on its own, but I need to go back to Access, and I've got this Access unit installed as an add-in here. I just invoke that, and it just is a tiny window. It's nothing special. It does not do much, except it creates two modules inside your application. One is the one we see here. It's a test factory. It's just a helper module to create class instances of the classes inside your application and passes references to those classes to the outside, to the add-in. And the other one is a really small helper module. It's just called test. And it has these methods like test assert equal, and that can be actually extended or modified. So that is just a tiny helper here that is inserted into your application. And what I do now, I can go to the form and start the tests, and that is a tiny annoyance. The form lives in Access and it runs and modifies VBA code, so the VBA environment will come to the foreground. And I actually hardly noticed this because in my office at home I use two screens, and I put this window to another screen than the VBA window. And I only noticed this to being quite an annoyance while preparing the demo on the laptop. And now when we run tests, we can switch to a more detailed view, and then we see in here that are the tests in the test module I just ran. And for the first, you see that January 30 days, that is the comment I added to the assert condition. And the other ones, I just see actual and expected values. They match the test pass. The big bar on the top is green. Everything's fine. And well, that was how you convert such a basic test with debug assert to a test using a test framework. We will come to slightly more complicated tests soon. To test or not to test, or rather, what to test? First, a general advice: avoid redundancies. Test code is code, and in code you should not have redundancies. That is pretty obvious. And you should not have redundancies in tests. And sometimes you test things from different angles, like I would test my getInterestDays function directly, as I did in that demo, or I would test if interest is calculated correctly, like the real money amounts for a certain period of time, and that money calculation would internally use the interest day calculation. So if I test both, the test on the interest days is redundant, and that is something you would need to adjust if you at some date change the logic. So you need to be a little bit careful to not introduce too much redundancies into your test code, because also the test code needs to be maintained, obviously. Don't test internal implementations for the very same reason. If you got a class with a private function, you're probably not supposed to test the private function. It would be difficult to implement that anyway, but don't even try. It's private for a reason. It might change any time, and no one on the outside should know about that. So don't test any private methods. Instead, test public interfaces. If you've got a public function in your code that is called from everywhere, or you've got a class that has a couple of public methods, test those, not internal stuff, because those public interfaces or public functions, they will probably be fairly consistent over time, or if you do change them, the change will already spread all over your application, and you need to adjust in lots of places for the changed interface, and then you can address your tests as well. Don't test the user interface. I tried. It doesn't work. It doesn't work in Access, and it's also pretty hard in other applications. Even if you use sophisticated tools like the coded UI feature of Visual Studio, testing the user interface is a pain. User interface tests break easily. They sometimes don't work for whatever reason, because your aunt sneezed in the next room or whatever. Just don't test the user interface. What about the database? That is something idealistic unit test experts or test experts would say, don't test the database. At least try not to test it. But working with Access, we enjoy all those close integration of the database to our VBA code. You just need a single line of code to query the database and get all sorts of data objects back. And data is everywhere in Access. So, well, I say if you cannot test in isolation without losing too much, then just test the integration. And that is where our next demo comes in. I have got a module customer, and it has a function find customer. And that is a really simple function. You pass in a company name as a search criteria. Then there is a simple select query here. Try to skim over that. And then we open the record set with that query. We create a new customer class. We read the data from the data set inside that class and add all class instances of found customers to a collection. And finally, we return that collection to the caller, and that can do something with that. And yes, I hear you, reading data and creating classes and using collections is probably not what you're usually doing. I'll address that in a minute. Let's just try to test this stuff. And to not run over, I am going to use a template code, because actually coding that would certainly make me going over time here. So I just created a new class module. I name this one test_customer. And here are a couple of tests in there. And actually here you see I put in comments to show the pattern I mentioned earlier with arrange, act, assert. And this is a very, very simple test here to find a customer that is not existing and actually verify our function does not find anything then. And the first thing is I arrange, I add a customer. And that is a small function I created. Unfortunately, I can't scroll there easily. That's super basic. I just open a record set, put a record in there. It's trivial. But the important part is, if I want to test with data, I should rather make sure in my tests that the data is there. And that's what I do. I add a customer because if I want to verify that this function does not find any customer, I should make sure there is at least one that could be found. And the act thing is I just call my find customer function with a strong, with a long string that does not exist in my customer base. And then finally I do the assert, and I do assert equal 0 to collection count, so my customer collection from that find function does not return any customers, and then that is good. The test passed. And another test is doing it the other way around. It's find customer one result, and once again I do the same pattern. I add a customer, and that is actually the customer I want to find. I add the customer to the database, that would be arrange. Then I query the database using my find customer function that will return the collection containing the customer. Then I assert that my collection count equals 1, because I was expecting to find one customer, so it should be exactly 1. And then additionally I assign the only customer object to a customer object and assert, the customer name of the found customer is exactly the one I just added to the database, and that is the customer I was expecting to find. So this works almost. So I was just saving this stuff, and to pick up new test modules you need to close the form and start it once again. And now I start my test and the window hides, and there's a problem. The test failed. And, excuse me, I zoom that. My test find customer one result failed. It said, actually there are 2 customers matching your search and you expected only one. I look in the customer table. Oh yes, indeed, there are 2 customers. And because I was looking for Acme Corp as a search criteria, both of them were found. So, and the cause of that is quite obvious if we think about it. I'll just disable the test I just wrote and switch to one I prepared earlier. It's almost the same. There's just one difference. I added a class, an instance variable, a collection, and during my add customer helper method here, I just add the ID of the customer I just added to the database. I add it to the collection and store that for later. And now this is a fine example for my 2 methods I mentioned earlier from the testing framework, setup and teardown. In setup, I assign my internal collection variable to a new collection, so I clear out anything that was in there before. Then in my test, you see the add customer. Any customer that I add with this helper function is stored in that collection. And finally, after the test completed, the framework will call the teardown method. And what I do in the teardown is just looping through all these customer IDs I collected during the test and delete them. And the rest here is basically, if you look at the actual tests here, they are exactly the same as they have been a minute ago. But just let me delete those old test records. Now I once again will invoke the test runner here. Just made a tiny mistake. To run it again. Excuse me. Yeah, obviously I forgot to rename the class module. I put a disabled in front, so the testing framework was not picking that up. And I delete another bit of stuff here. So now I need to close this and open it again for it to pick up the new tests. And now you see this is my new test customer delete. And it all worked fine. I switch to the all details view and I run this and run it again and run it again and run it again, and you see it all still works, because now I make sure before running the test, I create the precondition, then I run the test, and afterwards I clean up and eliminate all data that was created by my test that might confuse other tests. So each test, it can run or can verify its stuff in isolation and is reproducible. It does not depend on the state of the database before starting the tests, and it cleans up afterwards for new tests to run from a clean slate. So, and there is also one thing in my new test module included that I promised you. Here is another function, another test. I named it find customer record set one result. It's basically the same as I did before with the collection, but it's using a plain record set. I created another function in here that is almost identical. It's just find customer record set, and that is what you probably will do much more frequently than working with class instances and collections. Just querying a record set, returning the record set, and you can do anything with the record set you like. And the test does work almost identical to the previous one. I just assert the record count of the record set is 1, and then I assert that the company name in the first record that is returned equals the company name I was expecting to find. So this is something that you can easily apply to the way you work with Access now. If you have a function that opens a record set and you do something with that, you can easily test it. And of course, you can open the record set and put it as the record set of a form or whatever and glue it to the user interface later. So you can, with a little bit of structuring with testing in mind, you can test in Access without doing actually too much differently than before. And just for completeness sake, I would like to show you another tiny test. It's almost the same, except that it does not really store the record IDs and delete them. It's just another option to do the same thing. You just see my setup and teardown methods, and in setup I just say DB engine begin trans. I start a transaction, and then I do my testing as before. The test code is exactly as before, and after the test finished, the teardown method is called, and I just do a rollback, and the data is eliminated from the database. So which one is better depends. I would, if your application logic allows it, I would rather recommend the begin transaction, rollback transaction stuff. But sometimes you have got logic you want to test that actually needs to commit the transaction within its application logic. And if that is the case, that will obviously not work, because if your test commits, or the production code you are testing commits the changes to the database, the rollback afterwards will not do anything anymore, and the data is in there. Then you will have to resort to the approach I showed earlier with like the remembering the values you added to the database and deleting them later. So, I'm almost done. Have you got any questions? Silence.
I'm just trying to think of a way how to work this into an import feature I'm doing, which transforms an Excel file into records and database in about half an hour.
That is difficult to do. It's really, really difficult. Just an idea, because there seem to be no other questions. I'll address that in a little bit more detail. I would try to minimize the Excel sheet to the bare essentials, like put one record of each type that is different than all the other types in there, so that it imports and transforms quite quickly. Then it's difficult, because that are the parts you would usually try to eliminate. But if you have to test it and want to test it, yeah, then reduce the size as much as possible. Maybe create even a small procedure that creates your minimized Excel sheet before you try the import. Try to make it run within a couple of seconds, and then try that the results exist in the database. It is not the ideal scenario for a test, because there are lots of moving parts and that might break. It's not ideal, but it can be done. If there's a lot of logic in there, maybe you can look at the logic if you can extract bits of these transformation logic into individual classes, functions, procedures, and test them individually. But it's really hard. And actually, my basic, the example from my claim calculation was quite close to that, because that is you enter data in lots of tables and configuration stuff, and then this is processed by SQL Server procedures. And I actually work a little bit like I outlined. I enter all the data and run the import, and then verify that the results are what I expected. Yes, please?
I think this test you added some a lot of modules and procedures to your production code maybe. So how do you manage that not to apply these test classes in your final product? Do you leave them inside the final product? Do you do some separate database?
Well, it depends. Most of the time I leave them in the final product, because we compile an ACCDE anyway, and they don't do any harm. If a user does not have permission to do these operations, they will not work. The tests would fail if someone gets the crazy idea to kind of connect to the VBA project and run the tests. They can't do any harm. But you could also just remove them. If they all start with test underscore, you could easily just delete all the stuff. And there's one rule you need to keep in mind. You must never, from production code, use any function or whatever that was just meant as a test. That should be pretty logical. But if you adhere to that, you can just delete it, you can keep it, doesn't matter much. All right, sorry for switching off. I don't care how you do it, but I think automatic testing is a skill everybody should learn and know. Thank you very much.